everyone. Welcome to the talk of practice of securing Kubernetes. Just a few words about myself, and we'll get right into it. Okay, we don't have a lot of time, and securing Kubernetes is a serious thing, and it takes a lot of time, and we don't have a lot. So I'm Ben. I'm a CTO and co-founder at Armo, which is an Israeli Kubernetes security startup. We are the maintainers of Kubescape, which is an open source security tool for securing Kubernetes clusters. I won't spend too much time on myself. I have to tell you that I'm an experienced presenter at Devoxx, because an hour and a half ago I presented a different talk, so I can already tell myself that I am very, very experienced here. But talking about ourselves and mostly about Kubescape. Kubescape is an open source project. We are going to be part of CNCF hopefully next month. And most of the things which we are talking about here, you can automatize with Kubescape. And Armo is behind this tool, so check us out. So the first thing first, okay, I want to clear out a little bit of room, okay? As I told you, securing a Kubernetes cluster is a complex thing, and I want to define what we are going to talk about and what we are not going to talk about. So today, when talking about Kubernetes clusters, we are talking about many layers of protection, okay? And as you can see on the screen, on the slide, okay, there are different parts, okay, which are today published or talked about as Kubernetes security. Things like vulnerability scanning of applications which are running inside Kubernetes clusters, hence my previous talk. And also things about different vulnerabilities and container escapes in the Linux kernel, which are affecting Kubernetes clusters, but they are not necessarily integral vulnerabilities inside the Kubernetes software itself. So therefore, we have to, as a first of this talk, we have to define what we are going to talk about, and I have to tell you that the things which we are going to focus on today is the actually control plane components of Kubernetes. So we are not going to talk about application security inside Kubernetes, and we're not going to talk about one of my most important researches, which is around configurations and misconfigurations about Kubernetes workloads. What we are going to talk about is the security of the control plane component. Now, how many of you running Kubernetes in a managed environment in Amazon, in Google? I want to see the hands up. So guys, I'm going to tell you that I'm sorry, but this is not. We are not going to touch this, okay? Because the interesting part we are going to talk about is mostly things which the cloud provider is already taking care of for you, or at least is trying to implement instead of you. But I think it's really interesting. It's going to be interesting for you from the other side, because you will see what are the things which actually the cloud provider solves for you, and for all the others who are running Kubernetes by themselves or using some neat distro, okay, you will also meet some of the things which we are going to talk about. So we're going to talk about the security of the API server. API server is an integral part of a Kubernetes cluster. Okay, without it, we cannot, the whole thing is unusable. The API server is the main contact with the Kubernetes cluster, and its security is obviously paramount for many reasons. But you will see that from the very, very basic reason that simply this is the way someone can control your Kubernetes cluster, and if you're losing control of it, more or less you're doomed. We are going to talk about the Cubelet, okay, the actual component, which is, I would say, the component which is taking care of a Kubernetes node and running containers on a Kubernetes node. And kubelets are really integral part of the security. They have a very specific, intimate relations with the API server, and their importance is as well high. Okay, and we'll spend really a few words about the etcd, which is, you can say that it's the part of the API server to some extent, because this is the data backend of the API server, and actually the whole state of the cluster is stored inside the etcd. Therefore, it's pretty important. But we are not going to talk about the controller manager, and we won't talk about the kubeproxy neither, and also not the scheduler. These are very important parts of the Kubernetes cluster, but mainly they are not really. I'm not saying that there are no threats, of running these, but they are not really interesting threats, and they're more or less easy to manage and to run them securely. So let's hop into API server. So if you ever run API server, one of the basic configurations of a Kubernetes API server is actually the authentication. The authentication part is really interesting. You have multiple options of configuring how a Kubernetes API server is authenticating its client. There is a way to configure API server not to do authentication, which is obviously not an ideal solution for a production system. It is more for development environment. But in general, there is a client-side authentication of the API server, where the API server is trying to authenticate who's the client who's talking to it. And the simplest solution is to configure it to identify the clients using mutual TLS based on private keys and certificates, and use the client authentication, which is optional in TLS, to authenticate the client. For this, obviously, the client needs to have not just a private key, but a certificate that the API server accepts. And the other option is to have token-based authentication. In this case, the API server creates a one-sided TLS, which is the standard TLS we all know from Amazon and our online banking, and will authenticate the client using a token. Now, this token can come from different sources. The token can come from an OpenID protocol, where the OpenID, when the authentication actually happens against an external server, which is an OpenID identity provider service, and the API server is actually, in this case, delegates the authentication to it, and the part which the API server does is authenticating the token the client comes with. Other part is that where there are specific cases when there are internal tokens, for example, service accounts. Kubernetes service accounts now a way of Kubernetes workloads to identify themselves against an API server, and they are coming with what they call service account token, which is signed by the API server itself and injected to the workload. And there is an option to authenticate clients using passwords, which is, again, it's not a production grade solution, but there are sometimes very, very specific reasons to hard code some of the passwords into the configuration of an API server for authenticating a client. Now, as you can see, all these things you've heard of up until now all of them are using top-notch industry-wide accepted cryptography and security protocols, TLS, JW tokens, and so on. Therefore, I would say that the attacker and also the defender are most likely have to deal a lot with the protocols themselves. But from an operator perspective, the rotation of keys is going to be important, because this is the only way where the operator can protect against leaked secrets, and there is no way an API server to revoke manage revocation information of certificates or tokens. Therefore, rotation is key rotation is an important thing. And as I told you, for example, in the case of cloud managed Kubernetes, this is more this is managed usually by the cloud vendor itself. Now, this brings us to authorization. So, for example, we've passed the phase of authentication. The API server knows who's talking to. Now we need to enable the API server to give different permissions to different users in the system. Kubernetes started with the first Kubernetes versions came with what they called ABAC, or attribute-based control, attribute-based access control, which was more or less phased out after 3-4 years. And today, nearly, I don't really know of any who is actively installing Kubernetes clusters with and uses ABAC, but it's there. You could encode into the configuration files of the API server different access control objects and manage them statically. And sometimes you needed to even to restart the API server in order to add permissions to a new player. Obviously, this wasn't a scalable solution, and today we are more or less only using API authorization with Arbuck, role-based access control, which are actually Kubernetes objects which can be through which you can manage access control to different different resources with different access levels. There is a way to configure an API server with what is called a webhook-based decision delegation. Okay, when you want to enable an external entity to decide which API calls are acceptable and which API calls aren't. But for this, obviously, you need to bring up an external service to do this for you and encode it. There is a way, an authorization strategy, which is called node authorization. This is only, as its name shows, it's only for Kubernetes nodes, so you can give them specific access rights. And there is always an option for development purposes to actually disable authorization and enable every API to everyone, which is called the always allow strategy. But this is obviously not for production. So a few words about Kubernetes Arbuck, which is the prevalent way of managing access control in Kubernetes. So actually, it's a way to, on the one hand, define roles, which are actually access rights to different paths. In the request, the path contains API group and resource names. For example, app v1 deployment. And the verb, okay, which can be an HTTP word like get, put, push, delete, and so on. And you can define these roles and bind them using the role binding object to subjects. Now, in Arbuck, Kubernetes Arbuck, there are three kinds of subjects. You can either define a user, a group, okay. These two are coming from the authentication phase. For example, in case of certificate authentication or JWT token-based authentication from the certificate or the token, and they are, and you can manage, the role binding based on them, or you can bind the roles to service accounts, which I told you about. Is also coming from a token. From Kubernetes, where you can define a role binding for a given service account, giving access to the API server for specific workloads or group of workloads. So one of the key principles here is actually, like in every access control system, is the least privilege principle. So it is very hard, but as I can tell you that in the very most cases, when we are managing Kubernetes clusters, okay, we might use Arbuck for workloads inside the Kubernetes cluster to define what the service account can do and cannot. But I think that in most cases, when we are using CD tools For example, Jenkins, which is pushing changes into a cluster, in most cases it uses admin privileges, cluster admin privileges, which is obviously not a great idea in case we are losing access credentials. Therefore, managing and investing in access control is really important. Another interesting thing, if we are talking about Kubernetes API security, is admission controlling. Admission controller is a concept in Kubernetes API, a mechanism which enables extending the API server authorization mechanisms. Since the Arbuck is only limited, although it's a very good approach, but it's limited to the header of the HTTP requests against the API server. If we want to create policies and authorizations which are more fine-grained, looking inside the resources which are being updated or pushed to a cluster, it is not helpful. It won't help. So therefore, admission controller is an extension, an API through which you can extend authorization and access control of Kubernetes cluster to way deeper into Kubernetes objects when they are being accepted to the cluster. There are two examples of OPA Gatekeeper and Kyverno, two projects which are open source projects which are giving you out of box solutions to creating policies of the API server. Audit logging. When you're installing an API server, one of the options when you're running the API server is where you're sending your audit server logs. So the API server, every action which is accepted or not accepted in the API server can be logged either to a file, which is obviously not scalable, or can be moved to other outside webhooks, streamed into another system. Audit logging of API server is very important. Okay, and any kind of attack or problems or any kind of anomaly detection needs audit logging. And in general, it's a very, very basic security requirement of any Kubernetes API server. If you're running again a cloud-managed cluster, every cloud which I know is already out of the box giving you an option to send all the audit logs into their logging systems or AWS audit trail and so on. You can save all these logs and obviously pay a lot for them to be stored, but you can also use open source solutions like Prometheus to sync this data in. So if we are looking all the things which I told you already, and you are looking an API server deployment, okay, obviously there are going to be here very important artifacts you have to take care of, okay, in case of an API server. So there is the TLS identity of the API server facing the clients, okay, the private key, the certificate, the CA bundle, okay. If someone is able to steal this, okay, he can masquerade himself as an API server and receive all the traffic, and no client will be able to distinguish between the original API server and the stolen one. The API server is talking to the Cubelet, okay, and authenticating itself against the Kubelets with a private key and a certificate. The same goes here. If you don't want to lose, the protection of the communication channel between you and the Kubelets, you have to take care of these keys. There are other configuration files, for example, the keys through which service account tokens are signed and encrypted are very important to protect. The SSL keys through which the API server talks to etcd. These are all our precious, parts of an API server installation, and anyone who is thinking of installing by himself an API server and managing it has to take care of these things very good in order to create a secure API server installation. There's also another configuration API server which is called anonymous access. Okay, it's also for testing. You have to make sure that it's not enabled in your environment. Otherwise, anyone who has access to this port can do anything with the API server they want. Usually this is off by default. So a few words about etcd. So again, etcd is actually very bound to the API server. This is actually stores the state of the Kubernetes cluster. It has its own access control mechanism, which is more or less not used when etcd is run as part of the Kubernetes. Only the API server is the only one who gets access to the etcd through TLS private keys. But on the other hand, the API server is actually an admin on this system. So therefore, there is no really it's not really complex. But the API server, you can configure the API server to encrypt all the secret data it sends to etcd. So etcd is actually will only see encrypted secret, which is a neat configuration. And I really say to you that if you're running configuring your own API server in your own cluster, use the etcd encryption feature. This means that the etcd is more or less useless if an attacker tries to take over it, because only the API server understands all the data that is stored there. The third thing which we are talking today about is the kubelet. Okay, the kubelet, right, is the component in every Kubernetes node which actually manages the containers which are running on a given node specifically. It has also a mini API server. It's not obviously it's not the same component as the big API server, but it has the API looks very similar, and there is a listening port. It's usually 10 to 50, which is published by a kubelet, and this is the way through this port is receives the requests from other Kubernetes components. It also has what they call a read-only port, which is part of the Kubelet API. Is published through the read-only port. It publishes metrics and different state APIs. It should be disabled. Okay, there is no real reason, I think, today to publish it, and only enable those who have keys to access this information. The same goes for anonymous authentication. It's only for testing. Make sure that you're disabling it. And in the same sense as the big API server, the Kubelet API itself is also using either certificate-based client authentication or token-based authentication. The same goes as big API server. Now, the same sensitive files it stores is one of the important things is the CA bundle file. The CA bundle file contains the root certificate through which all the clients should be signed with. Therefore, if someone is able to change the CA bundle file on a Kubernetes node, it can cause the kubelet to accept certificates which weren't signed originally by the parts of the system who meant to use these connections. Therefore, it is important to protect it. Same goes for the private key and certificate of the node itself. Usually every node, it has its own private key and the certificate file through which the API server knows that it talks to the right node. It is important, obviously, to protect it. And all the token webhook secrets it stores, these are all three things which have to be protected on a Kubernetes node pretty much. And just for the sake of for you to understand, if an attacker is able to penetrate a Kubernetes node by getting into a container and make a container escape through the kernel, it can steal all these files and itself take over the Kubernetes cluster. Therefore, these are really important. And for example, there are cloud providers who are not storing this information, these private keys inside the file system, but on a secure chip inside the virtual machine node. So the limit to all these files should be limited. really much by the standard Linux file access configuration. And the network access to Kubernetes nodes should be in general limited pretty much. Okay, there are no reasons for the Kubelet API to be published in the internet. There's no reason to simply, okay, sometimes, okay, in development systems we are opening it so, we can debug a specific node, but in general there is no reason, okay, and all the Kubelet ports should be hidden, okay, from the outside world, and only for the, should be enabled to be accessed from the API server and the specific control plane component. The only place where we need to enable incoming traffic is only to bring in traffic to Kubernetes workloads inside the node, and these are the only exceptions where we should open ports. There's no other reason. So the last thing I wanted to tell you, and I think it's more an interesting thing to talk about, is node bootstrapping. So I don't know if you noted, but on the one hand, both the API server and the Kubelet has this very interesting, intimate relationship with one another. Okay, both of them have a private key. Both of them have a certificate which are sending to the other side, and they are doing this handshake where they are accepting the connection from each other. So the question is how this connection came to be for the first place. So if I'm trying to, I have an API server which is running, I want to bring up a new node under Kubernetes. Okay, how am I assigning a private key to the node, creating a certificate which is accepted by the API server? And here is obviously a chicken and egg problem, okay, because if the API server knew about the new node, there is no need to registration, okay, but there is no way it knew because we just want to decide that we want to bring it up. So there is what is called the Bootstrap protocol, okay, which is an interesting protocol in the sense that there is a very specific role inside the Kubernetes Arbuck, which is called Bootstrappers, okay, which enables you to request a one-time token, Bootstrap token for a new node, add this token to the kubelet which starts right now. The only thing the kubelet can do with this token is to come to the API server and request a certificate for its private key. So that's the only thing it can do, and this is the way they are doing their first handshake. And it goes very shortly. It goes like this: the kubelet starts up, finds this Bootstrap's token, okay, which was placed there on the VM. And it takes this Bootstrap token to the API server with a CSR, a certificate signing request. It just created on its generated private key file and says to the API server, well, I'm going to be your new node. Please sign me this certificate. Then the API server signs the certificate, returns it to the new node, and from there on, they can go using mutual TLS to talk and authenticate one another using mutual TLS. So this is what I could do in 28 minutes about protecting, control plane components. We have 2 more minutes. If there are questions, I will try to answer. Okay, thank you very much, guys.